Let's continue looking at numerical differentiation. And in the previous video, we've looked at question 1. Okay, you can check out the link of the video in the description as well as the playlist for the whole topic. Okay, so we are going to look at question 2 in this video, which says let f of x be equals to x to the power 3 multiplied by e to the power x squared minus sine x for h is equals to 0 0.1 and h is equals to 0 0.01. We have to approximate f prime of 2.19 using central difference formula and the 3-point endpoint formula. Okay, so this question is pretty straightforward. It's just a matter of knowing exactly what you're supposed to do. It's pretty straightforward. Of course, it can be involving in terms of like having a lot of computations to do, but the question itself is pretty straightforward. So I have my function f of x as equals to x to the power 3 by e to the x squared minus sine x. Okay, so we are looking to approximate f prime of 2.19 using the central difference formula as well as the 3-point endpoint formula. So I'm going to start with the central difference formula. Okay, central difference formula, that's more like the 3-point midpoint formula. Central difference formula. So what this does, or what this gives us, is that the formula itself is given in the form f prime of x naught is equals to 1 over 2h. Here you have your f of x naught plus h minus f of x naught minus h. There's an error part here, I'm not including it for now. Okay, so remember the question is asking us to use h is equals to 0 0.1 and h is equals to 0 0.01. So we are using two different values of h to approximate um, the same value, which is f prime of 2.19. So we are going to do some comparisons at the end so that we see which one is more accurate compared to the actual value. Okay, so all we have to do now is to perform some substitutions. So it will be f prime of uh, 2.19 would be equals to 1 over. So let me I've started with h is equals to 0.1. That's what I've started with. So this is going to be 2 open bracket where this h put 0.1. So this will be f of your x naught. Your x naught is 2.19 plus your h, which is 0.1. So if you do some addition there, this is just going to be f of 2.29. Okay, so minus, if you say 2.19 minus 0.1, that's just going to be 2.18, like that. Is it 18? No. It's not supposed to be 18. It's supposed to be 09. Okay, 09 there, like that. Okay, so one thing about this question is that you don't have a data table, okay, where all the results are given, such as the result for this one and the result for that one is given. You don't have, so you have to do the computations and substitutions yourself. So all you have to do is now to come to the main function itself, which is this one, and do the substitution. So we're going to say f of, you start with 2.29 is equals to meaning we are going to say it is here we said 2.29 to the power 3 by e. Here it will be 2.29 to the power 2 minus sine, okay, sine 2.29. So for this one, in short, to say whenever you're dealing with trig functions, just make sure that your calculator is in radians. So for here, I found that if you do everything right, like if you punch this correctly on your calculator, so what you're going to end up with is something like this. The value is going to be 2 point. Is it 2 point? No, no, no. It's 2000 actually. So I'm just trying to move this part. So it's 2274.293 446. I'm not rounding these values. Okay, so you do the same for the second one. F of 2.09 is equals to, so it will be 2.09 to the power 3 e, then 2.09 to the power 2 minus sine of 2.09. What you're going to have here is 719.3773371, like that. Okay, so that's what we have gotten right there. So our final answer, after if you punch that on your calculator, our final answer is just going to end up to be 7,700,580545. Okay, so I'll be doing a lot of erasing, so just make sure to say you save these values somewhere, because we are going to do some comparisons at the end. We see which one is more accurate. Okay, so that's what we have gotten right there. Okay, so you have to save that value. I myself have saved it somewhere. Okay, so that is when we use that's the central difference. That's the value of the that's the approximation when you use h is equals to 0.1. So now let's try to use another value of h, but we are still under the central difference. Our value of h, let it now be 0.01. Okay, so we're still going to use the same formula, which is this one, our central difference. So it will be f prime of 2.19. We're still trying to approximate the same value. It is 1 over 2 open bracket 0. It's not 0.1 now, but it's 0.01. It's a different value of h. So for this one here, it's more like you say 2.19 plus 0.01. Okay, so here this is just going to be f of 2.2 minus f of, here you say 2.19 minus 0.01, you end up with 2.18, like that. Okay, so just like we did again, we don't have a table of values, so what do we do? In the main function, just substitute. So here it will be f of 2.2. What is this going to be? It will be 2.2 to the power 3 multiplied by e to the power 2.2 squared minus sine 2.2. If you do everything right here, okay, if everything is right that you're going to do on your calculator, so here you're going to end up with your f of 2.2 to be equals to this would be 1345.837,161, like that. Then we subtract. So if we substitute here again, f of 2.18, which is this one, so this would be equals to 2.18 to the power 3 multiplied by e to the power 2.18 to the power 2 minus sine 2.18, like that, sine 2.18. So what do we now have? So here this will be 1199.53 7303, like this. Okay, so that's basically what we need. So for the central difference, on the first one, for the central difference, we have found that for this one we are going to we are going to get something like 7314 .9929. Remember, on the previous one we had something like 7774 point. That's what, that was 580545. Okay, so for the central difference, those are the values that we have gotten. So now we are going to save these values and we go to something else. Okay, so remember, we are using two sets of formulas. We are using the central difference, which you already have now, and the 3-point endpoint formula. Then we're going to do some comparisons at the end. So make sure to say those values that I've gotten, you have saved them somewhere. Then we are going to see which one is more accurate. So the second part is the 3-point endpoint formula. 3-point endpoint formula. So the 3-point endpoint formula is given in this form. Okay, I'm just going to write the part that we're going to use. The error part, I'm going to leave it out. Is f prime of x naught is equals to 1 over 2h open bracket minus 3 f of x naught plus 4 f of x naught plus h. There isn't enough space here. Okay, let me try to write it on the top. So we are still trying to approximate f prime of 2.19. So our formula, okay, let's see if we can squeeze it here. Our formula is f prime of x naught is equals to 1 over 2h open bracket, you have minus 3 f of x naught plus 4 f of x naught plus h minus f of x naught plus 2h. We have the error part on the outside, but I'm going to leave it out. So that's the formula that we're going to be using. So here we do the same. We are going to start with when h is equals to 0.1, just like we did in the previous one. Okay, so it simply means here it to be f prime of 2.19, which is our x naught, is equals to 1 over 2 multiplied by 0.1 here. Then in the brackets it will be minus 3. Then it will be f of our x naught. Our x naught is just 2.19. Okay, then plus 4 f of, so here if you put x naught, our x naught is 2.19 plus 0.1, we're going to end up with 2.29, just like in the previous one, minus this part as well. If you do your math, that's like 2.19 plus 2 multiplied by 0.1. That's going to be f of 2.339. Okay. Excuse me. So that's what we have. So once again, this one and this one we got in the previous part. It's just this one that seems to be new. We have to substitute. Okay, so remember to say our f, did we do, no, actually this one we didn't do. It's only this one that we did. Okay, so if you do your substitution, if you say f of 0. Is it, no, if you say f of 2.19, it will be equals to, you say 2.19 to the power 3 multiplied by e to the power 2.19 squared minus sine 2.19, there, like that. So this we are going to end up with, if you punch on a calculator, you're going to end up with something like 1270.497550, like that. Okay, then the second one, f of 2.29 is equals to, so for this one, as we substituted in the previous part, that gave us something like 2274.29346, like that. Okay, then the last part, which is 2.39. Okay, if you substitute just in the same way as I've done here, then you punch on your calculator, you're going to end up with 4129.1000014. By the way, I'm not rounding off these values. Okay, so if you do your substitutions here, okay, if we do all the substitutions that we are supposed to do, so here we have a 3 open bracket, okay, then this will be 1270.49750. Okay, I'm trying to see if I can reduce the size of my pen. Okay, then here we say it is plus 4 open bracket. Okay, I hope this is visible enough. So for that one, it is 2274.293446, like that. Then we say minus, the last part is simply 4129.1000014, and we close it like that. So if you punch all of this on your calculator, okay, if you punch all of this on your calculator, you're going to end up with some value f prime of 2.19. That is after you use the 3-point endpoint formula to be equals to 5782.92588. That's what you're going to end up with. So this is the third value that we have gotten. So let's go ahead and find the last one before we try to see which one is exact. So this was when h was equals to 0.1. Let's now try when h is equals to 0.01. Okay, so when you try for h is equals to 0.01, of course this still be f prime of 2.19 is equals to 1 over 2 open bracket 0.01. Then in these brackets we are going to have it will be minus 3. Here it will still be 2.19 plus 4. So for this part it will change. So we have 0.01 plus 2.19, which is our x naught. So this is just going to give us something like f of 2.2, okay, minus, for the last part we say 2.19, which is our x naught, plus 2 multiplied by 0.01. This is going to be f of 2.21, like that. Okay, so these questions are pretty straightforward. So if you do your substitutions again, one part is that if you say f of 2.19, what I mean is that this value, your 2.19, you substitute it in this f of x, we end up with what we end up with is something like 1270.497.550, We do the same to the second one. F of 2.2 is equals to, if you substitute, you're going to end up with 1345.837161. Then what about the last one? F of 2.21. This is just going to be equals to 1425.837769. As I said, I'm not rounding off these values, okay, because I want to ensure to say the answers that I'm getting are accurate. Okay, so here it's just a matter of substituting. Here you just put 1270.497550, then plus 4 open bracket, it will be 1345.83761, like that, minus the last one, which is 1427.8377769, and that's what we get. So here you just have to punch all of this on your calculator. Then what you're going to end up with is something like 7300.91125. So I hope you are saving all these values. Now let me find the exact value itself. Okay, let me find the exact value. So we have our f of x there. Let me differentiate this. So my f prime of x is simply equals to this part. You of course require to differentiate using the product rule, but when you differentiate it, you're going to end up with 3x to the power 2 plus 2x to the power 4 multiplied by e to the x squared minus cos x. How I'm coming up with this is that I've just used of course we know the derivative of this. For this one, just use a product rule. It's more like you have your x to the power 3, you have your e x squared there, like this. If I name this as my u, this as my v, when you differentiate, your dy dx is just going to be equals to u prime by v plus v prime by u. So if you differentiate u, you're going to get 3x to the power 2, then by v, which is e to the x squared, plus v prime. If you differentiate e to the power x squared, here what happens is that you're going to write e the way it is, e to the power x squared multiplied by the derivative of the power. That's how you differentiate exponentials. The derivative of the power is 2x, like that. Okay, so it simply means it's this is your v prime multiplied by u. What is your u? Your u is x to the power 3. So this becomes 2x to the power 4 e to the power x squared, and that's where that has come from. Okay, so what is the exact value? The exact value is f prime of 2.19. 2.19 is equals to here you're going to have 3. Let me use this kind of brackets. You're going to have 3 open bracket 2.19 squared plus 2 open bracket 2.19 to the power 4. We close, then e to the power 2.19 squared minus cos 2.19, ensuring that your calculator is in radians, and the value that you're going to end up with is equals to 7,310.449609. So that's our exact value. Okay, so let me take you back to the values that we've been getting. So the values that we have been getting is that when we use the central difference, okay, for the central difference, when h was equals to 0.1, our f prime of 0. Why am I using 0. is 2.19, sorry. The value that we found was 774.580545. Okay, when h was equals to 0.01, my f prime of 2.19, I found 7314.9929. Okay, so I'll bring back the exact value there. Then the second one, we use a 3-point endpoint. 3-point endpoint. What do we get? So for the 3-point endpoint, we ended up with these two values. So there is when h was equals to 0.1 and our f prime of 2.19, we got 5,782.92588, like that. When h was equals to 0.01, we ended up with f prime of 2.19 to be equals to 7,300.91125. Okay, so these are the values that we got. There's this one here, there's this one, there's this one, as well as there's this one. But our exact value, okay, exact value is equals to, our exact value is equals to 7,310.449,609. So what you want to do is that to check out which one of these, which formula is more accurate, and not only that, but on that particular formula itself, which one gives you which value of h gives you the most accurate value. Okay, so what you do is just a matter of, you get this value here, you subtract all of these. The one with the lowest the one that's going to give you something that is the lowest is the one that is more accurate. And what you do is that, if you observe, if you say 7,310.449609, if you subtract this one, you're going to get something that's a negative. But just take the absolute value, which is, I mean, like the positive value of it. So just subtract this one, subtract this one, subtract this one, subtract that one, and check which one is going to give you the lowest error. So what you get after you subtract is the error. And from my workings, the one that is the one that is going to, the one that is the closest, okay, the one that is the closest is actually this one here. Okay, you might be tempted to think it's this one, but come to think of it, this is 310, then this is 314, and that's 3 flat. So this one is more accurate, followed by this one, then this one is 2 off. Okay, this one is 2 off. This one here is 2 off this one a little bit, but this is more accurate, followed by that one. You can try it out. So that's all in this video. Thank you very much for watching, and I'll catch you in the next one.